Hello everyone, this is Shubham Chaudhary and I welcome you again in the 24th video of our YouTube channel. Today is 24th of January and we are discussing this LeetCode medium problem number 1457, pseudo-palindromic paths in a binary tree. Here they have given a binary tree where node values are digits from 1 to n, and a path in the binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is a palindrome, and we need to return the number of pseudo-palindromic paths going from the root node to leaf nodes. Now, what are the pseudo-palindromic paths? So let's discuss in the first example. Here, this is a binary tree in the array form here 2, 3, 1, 3, 1 null and 1. So there are three paths here from root node to leaf node. First path is this red line, second path is green line, and third path is 2, 3 and then 3, 1, this black line. So we need to calculate number of pseudo palindromic paths. Now what are the pseudo palindromic paths here? So in the first path 2, 3, 3, we can arrange this in a way that it can be formed as a palindromic sequence. So when we take 2, 3, 3 here, we can arrange it as 3, 2, 2 here, this the red path 2, 3, 3, and it can be rearranged in 3, 2, 3. So 3, 2, 3 is a palindrome. So we will increment the count of pseudo palindromic path, and in the third path, this green path 2, 1, 1, we again rearrange this one to upper side and 2 in the middle one. So 1, 2, 1, this will form a palindrome and it is called as a pseudo palindromic path. So here there are two pseudo palindromic paths, so we will return 2 here. Now in the condition, in the path 2, 3, 1, all the values are unique, so we cannot return a pseudo palindromic path. Now in the second example, there are three paths here 2, 1, 1 from root node to leaf node only. So 2, 1, 1, this green one, then 2, 1, this black one, and then 2, 1, 3, 1, this green plus black path. It will count as 1. So in these three paths, the 2, 1, 1, we can rearrange this one middle one to side one, so we can form 1, 2, 1 as a palindrome. And here this can be concluded as the pseudo palindromic sequence. So we will return 1 here, as we cannot form pseudo palindromic path with the two remaining ways, so we will return 1. And in the example 3, only 9 is the root node, so we will return 1 as a number itself a palindrome. So what should be the approach here? So the approach will be, we will use the DFS order, so we can traverse through this tree and we will create a stack to traverse the binary trails. For traversing the binary tree, we are using DFS plus stack. So after that, we will create a variable for tracking the occurrences of each digit using XOR operation. So we will create a variable named as path, and we will create it to store the track of the occurrences of each digit. So 2, how many times is present in the path, 3, how many times is present in the path. We will store that count in the path variable, and this can be done using the XOR operations. Those OR operations we will see in the code. After that, if we reach to leaf node, so after traversing, if we reach here at the last node of this path in the leaf node, then we will check if the current path is pseudo palindromic. If we reach to the leaf node, then we will check the current path is palindromic or not. pseudo-palindromic or not. And what are the conditions for that? Condition is simple. We will the path should contain at most one digit, should have odd frequency. So a palindrome is what? Palindrome is we can say that only one bit in the palindrome which will be of odd frequency, and all the other digits in the palindrome will be of even frequencies. So every element will present in 2 or 4 or 6, two multiples of 2, and only one, at most one bit will be present in the odd frequency. So it will be called as a palindrome, and we can rearrange it as we want. So we will only check that condition here, as it is saying at most one digit should have odd frequency. After that, we will use bitwise operations to efficiently handle digit occurrences. Now here, as we said, digit occurrences can be handled using bitwise operations. We will see in the code. And after that, we will increment the count if the pseudo-palindromic condition is satisfied. We will create a count variable and we will increment the count if the pseudo-palindromic condition is satisfied. So let's code for it. Before that, if you are new to the channel, hit the like button and also subscribe for more content. So create a count variable first, then we will create a path variable which will store the counts of frequencies of each digit. After that, we will create a stack for traversing. It will be a pair of stacks. So in the first value we will store the tree, and in the second we will store an integer. Let it call as stk. Then first we will push first element, root node, and assign it to 0 value. Sorry, and assign it to 0. Then with the help of stack we will traverse. So while stack is not empty, so we will take as stack.top, and for that our stack is a pair, so we will use auto here, auto node and path. So we will extract node and path variables from stack, and then we will pop out that element, top element. Now we have node and path, so we will check if node is not equal to null. If the node is not equal to null, then we will perform this operation, bitwise operation. We will say that path, update path to path XOR of 1 left shift node value. So this is a bitwise operation we are performing for checking if the node is not null. It will be for the every node, every general node, and we are storing here the counts using this operation. So it will, in the first of all, by the node value we will get the current digit, then we will use this one and left shift operator, then we will left shift this one in the number of times the node value is present, and after that we will perform this operation path XOR of this value. So we will get the count of the total count of how many times a digit is present. After that, so we will again apply a condition here. For if we get the root node, so we will apply the condition if node left is equals to null pointer and root right equals to null pointer. So this condition satisfies that the current node is a leaf node. Then apply the condition here if path and operation of path -1, if this equals to 0, we will increment the count variable. So basically this operation is performing as path -1 we will be using for here path -1 will give us the rightmost bit, and all the leftmost bits we will swap. I think all the leftmost bits will be we will swap. So this operation basically, if it gives 0, that means the element has the element has only one bit which is an odd occurrence. This condition we are talking about bit operation. This condition, at most one digit should be of odd frequency. So this bitwise operation we will give, and this if this bitwise operation satisfies, that means there is only one bit, or at most one digit which is of odd frequencies, because we are performing AND operation and the this operation. So only the rightmost bit will be present there, and all the other bits will be 0. If there are some digits in see, if there are some bits that are 1, so we can say that uh, that sequence has some digits with different odd occurrences, so that will be not a palindrome. And if this condition satisfies, the only one digit is present, which will be 1, so the the path will be palindrome, and then after that we will increment the count, as we want to return the count here. Else we will do here, if node is root node, then we will perform this. Else we will push the right node and left node in the stack. Else we will do what? We will push stk.push right node with path as the current count and left node and path as path. After that, after this while loop ends, we will return count. We are storing the pushing the path right node and left node, such that we can perform the operations for right subtree and left subtree. And after that we will return count here. So let's check for the solution. Something is wrong here. Here there was a syntax error. For checking the current node to be the leaf node or not, we will check root node left equals to null pointer, and here we will check node right for null pointer. So that's the correction. Yeah, the code ran successfully. Let's check for the hidden test cases. Yeah, solution submitted successfully. Here, talking about the time complexity, we are iterating through each of the nodes. We are iterating here and visiting every node. So it will be big O of n, where n equals to number of nodes, and the space complexity here will be the stack. As the stack is storing every tree node, so big O of n, as where n is the number of nodes present in the tree. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content. Your feedback and engagement are crucial as we build this community, and stay tuned for upcoming LeetCode problem of the day videos and exciting one-stack web development projects. Happy coding, and let's make this year a fantastic one together. Thank you.